going to show you two methods. The first method is pretty much how you would do, for example, what is a complex fraction? If I have 2/3 divided by 3/4, how would you do this complex fraction? That's what a complex fraction is. It's a fraction in the numerator and or the denominator. It has another fraction. It's complex. So the way we would do this one is I would take 2/3 and change this, and I would change this line to divide, and it's divided by 4/9. We don't change it. And now we know how to do this. This is 2/3 times 9/4. And we can simplify if we like, or multiply. I like simplifying personally. 2 goes into 4 2 times, 3 goes into 9 3 times, so my answer is 3/2. Or you can multiply across and then simplify by dividing. So that's the idea here. When you have it broken down to one fraction in the numerator, one fraction in the denominator, you can flip and multiply. So our steps is to combine the fractions in the numerator and denominator so you have one fraction. The second step is you want to then rewrite as a division problem. If you have A over B all over C over D, we're going to take this and rewrite. We rewrite this as A over B divided by C over D, and then you flip and multiply, and it's A over B times D over C. And then, of course, you're not going to multiply across unless there's no common factors that you can't cancel. So you'll factor and cancel factors to simplify, just like we did up there. Okay, so there's the instructions. So let's do one. Okay, so we're going to simplify this fraction. So what we're going to do is we're going to, up here, add, subtract fractions in the numerator and or the denominator. So basically we're going to add these two fractions and add these two fractions. Find a common denominator, just like you did on that last video, and combine them. So 1 over x plus 1 over y. My common denominator for the numerator is xy. My LCD is xy. We have an x here. We need the y on the bottom and the top. Here, I multiply top and bottom by x. And then on the bottom, we have 1 over y squared, 1 over x squared. And my LCD down here is x squared y squared. There's a minus there. So down here, I have to multiply top and bottom by, I'll do it in yellow, x squared. This one is y squared over y squared to fill in to get our LCD. Okay, so we're going to be adding these and adding these. So in the top here, it's y plus x all over xy. On the bottom, it's x squared minus y squared all over x squared y squared, and that's equal to the previous. And now that we've got one fraction up here, one fraction down here, we're able to flip and multiply because we'll have a reciprocal. So we're going to do that, 1 plus x over xy. This divide is going to become divide, and I copy the bottom. And now I can flip and multiply. I flip what you're dividing by. It's x squared y squared on top now, and x squared minus y squared on the bottom. Over here, we have y plus x, but you're free to write it, since they're both plus, as x plus y all over xy. And that is a times in the middle of them now. And so to simplify, we can factor. It's x plus y, x minus y, and we can go ahead and cancel one of these with one of those. Y on the bottom with one of the ones on the top. And this is, since those canceled over there, we have xy here, x plus y over 1 here. We can see also this x plus y cancels with an x plus y. And so now we're left with xy on top, x minus y on the bottom. It simplified pretty nicely there. And so again, just to recap, we need one fraction on the top, one fraction on the bottom. That's our goal, so we can flip and multiply. That's this process. Okay, so you got to find a common denominator. A lot of work to find a common denominator sometimes, but not always. Now, method 2 is the second method, and we'll do the same problem with method 2, and then maybe a couple others. Our method 2 is we're going to find the LCD. First step is find the LCD. And once we found that, then we're going to multiply numerator and denominator by that LCD. So it'll be the LCD over the LCD. But if you want, you can do LCD over 1, because it is a complex fraction, LCD over 1. And then what we'll do is we'll distribute this to the top, distribute the bottom one to the bottom, and that should clear all of our fractions. So then we will distribute and simplify as necessary. Okay, so let's do that same problem. Example, different process. So we have to sit here and say, hey, what's my LCD? My LCD, it's different. Before we just found the LCD of the numerator and then worked with that. But we need to look at the LCD of all 4 denominators. Okay, what number will clear all those fractions pretty much? And it's going to be x squared, y squared. Because between x squared and x, you have to take the bigger one because it's the common multiple. That's what a denominator is. Common denominator is. So I multiply x squared, y squared over 1 all over x squared, y squared over 1. So we take our LCD and multiply it top and bottom. Timesing it by 1 doesn't change anything. It just changes the appearance. We're going to distribute that to the numerator, distribute the bottom one to the denominator, and it should simplify a lot after that. So it's basically 1 over x plus 1 over y is my problem. And when I distribute, it's x squared, y squared to there over 1, x squared, y squared over 1. And on the bottom, we originally started with 1 over y squared minus 1 over x squared. And I take that x squared, y squared, and distribute it. Okay, it doesn't matter if you put it in the front or the back. It doesn't matter. And if you want to keep it over 1, again, that over 1 for both places is not really mandatory. So that's equal. We're doing a string of equals here. I'll work down. You can work down or across. It doesn't matter. So now let's simplify. Simplify this. There's an x that cancels here with just one of them. The y cancels here with just one of those y's. Both of these y's cancel, and both of these x's cancel. Okay, so like I said, this is almost the elimination method. It eliminates all of our fractions, complex fractions. So up here, the first term that I have circled, we're left with xy squared, right? Xy squared, no fraction, plus the second term here is x squared y is left, x squared y. And then on the bottom, so again, it cleared my fractions. On the bottom, it's just x squared minus y squared. We're not done. We have to simplify. How do we simplify? We factor, and like before, this is x plus y, x minus y. It's our difference of squares. Here we have common factors. The common factor is x is in each of the terms and y is in each of the terms. What's left? If I pull out an x, I pull out a y. If I pull out an x, I pull out a y, I'm left with just y. I pull out an x, I pull out a y, and there's a plus, because you're going to have this plus x. Okay? And now that we've factored looks like we can, y plus x cancels with an x plus y. They're the same term. And I'm left with the same answer as before, which is xy on the top, x minus y on the bottom. It's like it's the same answer. See that? So we've learned two different methods. The second method probably is the one I use the most in trig and whenever I need it. But every once in a while, I like the first method, like usually when I have more terms in it. So let's look at the second example. That's why. So this one doesn't have fractions all over the place. And since there's really only one fraction right here, I think the second method is much easier on this one. So if there's only one fraction, that fraction is your LCD. It's y. So again, I'm going to multiply the top by y, over 1 if you want to, and multiply the bottom by y. Okay, we don't need over 1 here. We're going to distribute. When I multiply it here, 36 over y times y, the y's cancel. And then minus y times y is y squared. Don't forget to multiply it to both terms. And then you don't really want to multiply this one because you'd be factoring it. We have to factor to simplify. But I could switch this to y plus 6. Oh no, we'll keep it. Looks like those are backwards up there too anyway. So now to simplify, we have to factor. The top is difference of squares. 6 plus y, 6 minus y, all over my denominator. And 6 plus y cancels with 6 plus y. And I'm left with 6 minus y over y. You can be done. Okay? And again, if I do go too fast, you should be pausing it, working it out on your own, and then checking it. You can play it back to see if you got it right. One more example. Again, this one, I'm going to go back to the first method because it's just, there's nothing in common with those three. My LCD would be x times x plus 3 times x plus 2, and you'd have to multiply both of them top and bottom. It just seems horrendous. So I'm going to utilize the first method on this one. So we need to find a common denominator up here. And for up here, your LCD is between x times x plus 2. There's no way to make that. You cannot add 2 to up, top, and bottom. So that is our LCD. And we don't need to touch our bottom because it's already one fraction, right? So finding that common denominator. So x plus 1 all over x plus 2 is already there. And what am I missing? I have an x plus 2. I need an x. So I'm going to have to wrap these to multiply it. X over x. And then the minus 1 over x is there. And what am I missing? So I have the x. I need the x plus 2. X plus 2. X plus 2. And then I'm going to multiply. I have my final answer. Oops, let's not forget about our complex fraction. This is all over 2 all over x plus 3. So don't lose pieces of it. So now, this is, in the numerator, it's x plus 2 in the denominator. I'm going to go ahead and distribute that. It's x squared plus x minus, you have to distribute both terms, minus x minus 2. All over 2 all over x plus 3. Okay, so here's our complex fraction. We've got it. Yeah, we've got to simplify that. We'll just cross it off and simplify it in the next thing that we write. Because we're going to turn this to a division, like so. Write what's in the front in the front. So in the front, it's x squared minus 2 all over x plus 2. And this is divided by 2 all over x plus 3. This becomes x squared minus 2 does not factor. And we have all over x plus 2 times x plus 3 all over 2. Nothing cancels. So that's going to be our answer. Okay, thank you for watching.